So in this example 2, we have if f of x equals to 132 to the base of x, we have to find the value of x when f of x equals to 42. This means f of x is 132 base x, and that f of x equals to 42. So what we need to do is to solve this equation now. 182 base x equals to 42. So we have to convert this number base back to its natural state, that is base 10. And to do that, we have 1 multiply x plus 3 multiply x plus 2 multiply x equals to 42. But when you do this, you take the power on, because each of the digits has multiplied the base, take the power from the right to the left. So the first power will be 0, 1, 2. So 1 times x squared is x squared plus 3x to the power of 1 is x. So 3 times x is x plus 2 times x to the power of 0 is 1. Any number to the power of 0 is 1 except 0 itself. So 1 times 2, that is 2, equals to 42. And this later becomes, we have recognized that the equation has become a quadratic one. So we have x squared plus 3x. If you move this one inward, you have 2 minus 42, which will give us minus 40 equals 0. So in this case, check, this quadratic equation can be solved by factorization method. Of course, you can use other methods. So in this case, the two values that you multiply, the two numbers that you multiply to give minus 40, and when you sum them to give plus 3, is positive 8 and negative 5. So since it's positive 8 and negative 5, and coefficient of this is 1, so we can factorize directly to have x plus 8 and x minus 5 equals 0. So if two expressions, two numbers multiply to give 0 as a result, that means one of them is 0. That means x plus 8 is 0 or x minus 5 is 0, which implies that x is negative 8 or x is a 5. But because base of a number can never be negative, neither can it be a fraction. So you must make your conclusion there. Therefore, x equals to 5. So, or you open another bracket as x cannot be negative 8. So this conclusion is necessary. We'll quickly move on to B part. In B part, we are given two different functions. We have g of x to be 3x squared plus kx plus c, and the second one is h of x. We're giving h of x as 3kx plus c. So additional information is that k and c are scalars. In this case, they are constants. They are any figure there, fixed figure. So in this function. So what we have is that, but we're giving additional information that if g of 1 is 2, that is, if you use 1 to replace x in this function, the result will be 2. So let's use 1 to replace x in this function. So we have g of 1 equals to, that is 3 into 1 squared plus k into 1 plus c, but they said the result will be 2. So g of 1 equals to 2. That when x is 1, the result of the whole function will be 2. So from here, we have 3 plus k plus c equals to 2, which when you simplify, you have two unknown in this equation, and that will give rise to, naming it, we have 2 minus 3, or let me just write 2 minus 3 is negative 1. So equals to minus 1. We call this equation 1, because you can solve a single equation with two unknown directly. unless you have some reason for to compare. So we leave it like this. We target equation 1. We go to the second one where we have h of x, but we are giving here that h of 1, the result will be 3. That is, if 1 replaces x in this function, the result will be 3. So we now have h of 1 as well. The function of h of 1 is 3kx. That will be 3k multiply the value of x, which is now 1, plus c, and the result is 3. H of 1 is 3. So let's simplify this. We have 3k times 1, that is 3k, plus c equals to 3. Equation 2. So if you look at what this has given us now, it is simultaneous equation. So you can use any method, either substitution method, elimination method, matrix inversion, or you can use Cramer's rule, anyone you prefer. So here I want to quickly make use of the what we call substitution method. From equation 1, I want to make C the subject of the formula. So we have C equals to -1 minus k, and I quickly call that equation 3. Since it is equation 1 that gives rise to equation 3, the result I will substitute in equation 2 for C. Wherever I see C, I replace it with -1 minus k. So from here we have 3k plus C. Instead of writing C back, this is the result for C here. We say -1 minus k, so equals to 3. It is this equation we want to quickly solve now. Let me continue from here. So here we have 3k minus k equals to 3 plus 1. When you collect like terms and you have 2k equals to 4, so that ultimately k becomes 2, dividing both sides by the coefficient of k. Since we have one of the unknown, and we know that k plus c here gives -1, or use equation 3, substitute k for k in 2 for k in equation 3. So in equation 3, we have c equals to -1 minus k, which is this. C equals to -3. Thus, the two constants that we call scalars here are k equals to 2 and c equals to -3. Do subscribe to this channel